Good day, everyone. So again, welcome to my virtual classroom. So we'll be talking about sets. Okay, but before I continue my discussions about sets, I would like to invite everyone who's watching to please subscribe to this channel for upcoming video lessons. And if you want, you can share this to your friends who happens to be taking mathematics and who happens to be interested in learning math. So you are free to share and invite them to subscribe to this channel. So much for that. So let's proceed. So sets. Sets is actually um, been concepts or lessons that you've been taking since you're in junior high school. Okay, so let us define set. So the definition is a set is a group of objects. Okay, a set is a group of objects. Say, for example, people in a class. So, specifically, say, for example, Alice, Bob, and Chris. Okay, another group. Okay, colors of a rainbow: red, orange, yellow, green, blue, purple. States of matter: solid, liquid, gas, and plasma. Province in the Philippines: Cavite, Laguna, Bulacan, and etc. Sets can contain also non-related elements. Say for example, 3, A, red, Virginia. Although a set can contain almost anything, we will most often use sets of numbers. So since you are taking mathematics, so um, we will most often use sets of numbers. So example, all positive numbers less than or equal to 5. What are those numbers less than or equal to 5? Of course, we have 1, 2, 3, 4, 5. A few selected real numbers. So we have 2.1, pi, 0, negative 6, 32, and e. So you have to take note of the characteristics of what is being asked or the characteristics of the set. Say, for example, all positive numbers. So that means we are only talking about positive numbers less than or equal to 5. Okay, so negative numbers are not included. A few selected real numbers. So only few selected real numbers. So take note of the characteristics. Okay, so next slide. Properties of set. What are the properties of set? So you have to take note of this. Okay, this is very important. Say, for example, order does not matter. So we often write them in order because it is easier for us to understand it. But order does not matter. Example, 1, 2, 3, 4, 5 is equivalent to set 3, 5, 2, 4, 1. So even though you haven't arranged this 3, 5, 4, 2, 1, so it's still equivalent to 1, 2, 3, 4, 5. And of course, we use the bracket. So sets uses the brackets to enclose the members of the set. And by the way, class, we call the members of the set as elements. The elements of the set. So we often use elements to denote or to identify the members in the set. Okay, another property of set. Sets do not have duplicate elements. So when we speak of duplicate, of course, uh, repetition of elements. We're talking about repeating elements. Okay, consider the set of vowels in the alphabet. Say for example, so it makes no sense to list them. Say for example, A, E, I, O, and U. Okay, so what we really want is just A, E, I, O, U. So we do not duplicate elements. So they are counted as one. And of course, we have to consider the list of students in the class. Okay, again, it does not make sense to list somebody twice. Okay, so except they have the same name but different surname. Okay, so or except they have the same first name and surname but they have different middle initial, so still they are different. So note that the list is like a set, but order does not matter and duplicate elements are allowed. Okay, we won't be studying list much in this uh, class, but since we're talking about sets, we have to explore naming sets. Okay, sets are usually represented by capital letter. Okay, so capital letter, say for example A, B, set A, B, S, and etc. Elements are usually represented by an italic lowercase letter. So elements in the set are, of course, use small letters only. It uses lowercase letter or small letters. Easiest way to specify a set is to list all the elements. So this is the number one naming of set, listing method. So you can jot down, okay, listing method. So you list all the elements. Say for example, elements, all positive numbers less than 5. So it's easier for you to list all the elements. But there's always a but. Not always, this is not always feasible for a large or infinite sets. Say for example, uh, if you want to list all the counting numbers, so it's infinite. Listing is not what's this? It's not appropriate, or its listing will be impossible. Okay, so listing method. So listing method is only for a smaller number or with definite number of elements. So take note of that. So sometimes if it is infinite, we use the ellipses or the three dots. Say for example, set B is equal to the set of counting numbers. So 0, 1, 2, 3. And instead of writing everything, so we use ellipses. So it means that this is continuous. Okay? So can usually ellipses can cause confusion. Consider the set C357. So what will be the next number for 357? So sometimes it's confusing. Okay, ito. So you just have to look at the patterns. But sometimes ellipses has a certain limitation. If the set is all odd integers greater than 2, if the set is all odd integers greater than 2, so 2, so this will be 357. Yes, so because uh, it has a definite uh, characteristics with which is all odd integers greater than 2, but of course less than 9. If the set is all prime numbers greater than 2, so 2, it is 11. So this particular example, set C, is giving us two different characteristics. Okay, so odd integers greater than 2 and prime numbers greater than 2 but less than 11. Okay, so this particular element, this particular example can cause confusion. So another one is using the set builder notation. Okay, say for example, set D is equal to the set of X such that X is prime and X is greater than 2. So set builder notation, this one is read as such that. Okay, so I'll repeat this one so you can follow me. Set D is a set of X such that X is prime and X is greater than 2. So another example. E is a set of X such that X is odd and X is greater than 2. I'll repeat. Set E is a set of X such that x is odd and x is greater than 2. So it's your turn. Will you please read this one? Okay, very good. So let's proceed. Okay, so again, I've mentioned already the vertical bar means such that. The set D is read in English as all elements, but you can also read this as set D is an element, set D is an element of X such that X is prime and X is greater than 2. Okay, or you can read it as set D is all elements X such that X is prime and X is greater than 2, whichever is comfortable for you. Okay, next. A set is said to contain the various members or elements that make up the set. Example, if an element A is a member of or an element of set S, we use the notation A, this symbol, vertical E. So you have to familiarize yourself with this this symbol. A is an element of set S. A is an element of set S. Example, 4 is an element of set 1, 2, 3, 4. If an element is not a member or an element of a set S, we use the notation the in the vertical the symbol for element just have to place a slash, okay, which means not element. Okay, so say for example, 7 is not an element of set S 1, 2, 3, 4. Pasay is not an element of set S 1, 2, 3, 4. So it's easy to understand the symbol for elements or not element. So take note of that. Okay, we have here often used sets. Okay, we classify the different numbers. So you have to familiarize also yourself with this one. Natural numbers are said to be denoted by big letter N. So N, and natural numbers, take note class, starts with 0. Natural numbers starts with 0, 1, 2, 3, and so on. So there's no negative numbers there. Okay? While Z is the set of integers. So this is a set of integers. That means this is composed of negative, 0, and positive numbers or positive numbers. Negative, 0, and positive is Z. So take note, Z is integer. N is natural number. Z plus denotes positive integer. So this is the set of positive integers or whole numbers. So that's why whole numbers class, whole numbers does not include 0. Whole numbers only include positive integers. Note that people disagree on the exact definition of whole numbers and natural numbers. So 0 is considered natural numbers and 1, 2, 3, 4, 5, and so on is considered whole number. And of course, we have the rational numbers, which is represented by Q. Okay, represented by Q. And this is always P over Q. Rational numbers also talks about fraction. That's why it's rational. So, rational numbers is a set of P over Q such that P is an element of Z, which is the integers. Q is an element also of the set of integers provided Q is not equal to 0. Why? Because if your Q is 0, that is unacceptable. Okay, there's no value for that. Any number divided by 0 is error. Even you try it in your calculator, say for example, 5 divided by 0 is error. Okay, so that's why here in rational number, the denominator should not be equal to 0. Why? Because it's represented by P over Q, right? So q must not be equal to 0. So that is the set of rational numbers. So that's the limitation. Any number can be expressed as a fraction of two integers provided the bottom one or the denominator must not be 0. Numerator is accepted because 0 divided by any integer is 0. And of course, R. R is the set of real numbers. So you have to take note of these representations. Again, N, natural numbers, Z, integers, Z plus, positive integers, or whole numbers, Q is rational numbers, and R is the set of real numbers. Okay, when talking about a set, we usually denote the set with a capital letter. Okay, so we have another type of naming a set. So we call this Rooster Notation. Rooster Notation is the method of describing a set by listing each element of the set. So example, let's see the set of all movies in which Angel Locsin appears. So what are the movies? 5 movies that Angel Locsin appears. So just give 5. So the Rooster Notation would be, let's see. So C equals the movies of Angel, Mano po, One More Try, and Officially Yours, Third Party. So those are the movies. Okay, 4 lang. Example, let set A the set of odd numbers greater than 0 and less than 10. What are odd numbers less than 10 but greater than 0? So the Rooster Notation of A will be 1, 3, 5, 7, 9. Because according to the characteristics, the description, the set of odd numbers must be less than 10 but greater than 0. 1 is greater than 0, 9 is less than 10. So this is now the answer. Okay? So this talks about notation. So we have 3. Okay, listing method. We have the set builder notation. Then we have the rooster notation. Okay? So more on notation. So we're heading towards the end of uh, this video lesson. So more annotation, sometimes you can list all the elements of a set. For instance, Z, the set of integer numbers, we can't write out all the integers because it's infinite. So we use the dot. I already mentioned this one. Set of integers, set of whole numbers or natural numbers. So we use the dot. Okay, so take note of that. Okay, another one. When it is convenient to list all the elements of a set, we use notation that employs the rules in which the element is a member of the set. This is called the set builder notation. So I am just generalizing everything. Example, B is a set of people such that citizens registered to vote in the Visayas. Another one, example of set builder notation. Set A is a set of x such that x is greater than 5. And again, this symbol is read as such that. Okay? And for the last slide, the universal set will be discussed on the next video. Okay, the different types of set. So that's all, guys. So if you have questions, if you have clarifications, you can comment down below, and we'll discuss all your questions and comments and clarification on the next video lesson. So thank you so much for joining me in this virtual classroom. So again, do not forget, if you haven't subscribed on this channel for the upcoming videos, please subscribe now. See you guys on the next video. Thank you so much.